Hi, and welcome to this Ignite Webcast. My name is Josh Topal, and I'm Program Manager for Office 365. So if you haven't joined us, Ignite events are a series of technical workshops for IT professionals and Microsoft partners. And the Ignite Webcast series will address different technical subjects and scenarios that are really beneficial to anyone who wants to increase their knowledge of the Office 365 suite. So for today's presentation, we are really excited to have Scott Schnoll as our Ignite Webcast presenter. And Scott is a principal technical writer on the Exchange user education team here at Microsoft. And he is a frequent speaker at a lot of major industry conferences such as Microsoft TechEd. So in today's webcast, Scott will discuss Exchange high availability and site resilience. And today's session provides really a great opportunity to hear directly from a Microsoft employee and learn more about Office 365 and some of the upcoming and present features that we have. So today's webcast will be about an hour, and we're going to leave a few minutes at the end to field any questions from anyone on the call. So you can go ahead and type those questions into the link chat box. I do recommend that you wait till the end, and then Scott will have more visibility into those questions, because right now he's just going to be presenting and focusing on that. So we are recording today's session, and we'll have the slideshow up that you're seeing now, or that you should see now, and the video on our original blog posts and on the YouTube channel and also on our Ignite website. And let me go ahead and paste those into the chat box right now. These are the different resources where you can find all of our information. So one last thing before we get started is that we are recording today's session. So please understand that you may be captured in today's recording, especially if you type a question into the link chat box. So if you don't wish to be recorded, please do not type in the IM window, or please feel free to leave the meeting and you can watch the video at a later time. So that's it for me. So Scott, whenever you're ready.
Great. Thanks so much, Josh, and thanks to all of you for attending today. I know that your time is at a premium, and we appreciate you joining us today. Today we're going to talk about Exchange Server 2013 high availability. The agenda is fairly straightforward. We're going to talk about the primary platform that we use for both high availability and site resilience within Exchange 2013. That would be the Database Availability Group. We're going to dive deep into the architecture and talk about the components in Exchange and in Windows failover clustering that we use as part of the high availability and site resilience platform. We're also going to talk about some questions around where to place your witness server for your database availability group, as our guidance is a little different in Exchange 2013. We're then going to talk about a new feature in Windows Server 2012 called Dynamic Quorum and what that means for your DAGs. We'll also get into how to do maintenance on DAG members, as that process has changed considerably over previous versions. And then we'll end up with a discussion of other new technology around high availability called managed availability as well. So again, thanks for joining us. So I want to start with the database availability group architecture. And I want to go through it in such a way where you'll end up with an understanding of all of the different components that actually work under the hood to provide you with high availability and site resilience for Exchange 2013. Now, what's interesting to note is the same technologies that I'm going to talk about, which of course will be in the context of an on-premises deployment, are the same exact technologies we use in Office 365. The primary difference between Office 365 and an on-premises deployment from an HA and site resilience standpoint is that there's zero administrative burden when you deploy in the cloud. So if you want high availability for Exchange 2013 with zero administrative burden, Office 365 is for you. If you're deploying on premises, well, that's on the administrator to configure and monitor and manage things. So again, let's start with the DAG architecture, and let's start with the core component of that architecture, and that would be the Microsoft Exchange Replication Service, or MS Exchange REPL as its short name. Now, this is a service that is not new in Exchange 2013, although it has undergone significant revisions since we first introduced it way back in Exchange 2007 RTM. And this is a service that runs on all mailbox servers, not just database availability group members. And it, in fact, is a required service for all normal mailbox operations. And I'll explain why that is in a moment. The primary purpose of this service is to communicate with Active Directory, to communicate with other DAG members, to provide an administrative interface for admin actions, and to provide other activities that introduce a level of automation that we hadn't had in previous versions of Exchange. Now, the replication service itself is unmanaged code, hence the short name MS Exchange REPL.exe. But it is a very core and important service. Without this service, you really don't have any mailbox functionality. Not only will you not have a database availability group, but you won't have any mounted mailbox databases as well. Now, inside the replication service are primarily 16 different components or functions that are doing different work. Some of them are self-explanatory. Others might need a little bit of an explanation. So let's start with the Active Directory lookup component. Obviously, a database availability group member needs to understand where a user's mailbox is located. The reason for that is largely due to an architectural change that we made in Exchange 2013. In 2010 and previous versions, much of the work in maintaining the application level session was handled by the middle tier, by the old client access and hub transport servers. Now, with the architectural changes that we have in 2013, all of the functionality in the entire session related to any user's mailbox access all happens completely on the mailbox role that hosts the active copy of their mailbox. So as a result, all mailbox servers need to know where a user's mailbox is located and whether it is mounted or dismounted. And that is in part what the Active Directory lookup component is there to do. There are components within the client access server, the new client access server, that will perform a lookup to locate this mailbox, and it will get the information in part from the Active Directory lookup component inside the replication service. The copy status lookup is there so that the DAG member can first provide that information to the administrator through the Exchange Admin Center or through the Exchange Management Shell. And second, so that the algorithm known as the best copy and server selection algorithm can also use database copy status and content indexing copy status as part of its selection criteria. Ideally, the algorithm is designed to only pick healthy databases for activations. The Replay Core Manager, as its name implies, is there as the core functionality to handle log shipping and replay. So a lot of communication takes place between DAG members through that component. That component is also responsible for storing data inside the cluster database, which I'll show you later on, and retrieving that data in the context of figuring out where we are within the continuous replication pipeline. The Seed Manager and the Auto Reseed Manager, they perform similar functions. The Seeding Manager is there to manage seeding operations that either happen automatically when you create your initial database copies, or that happen manually when the administrator is performing a reseed operation for a variety of reasons. Now, the Auto Reseed Manager is there as part of a new feature that we introduced called Auto Reseed in Exchange 2013. And it works together with the Disk Reclaimer Manager to basically grab a spare disk that has been pre-provisioned by an administrator and use that disk as a replacement for a failed disk. Once the spare disk has been allocated and mapped into a specific mount structure, the Auto Reseed Manager will go ahead and fire off an automatic reseed of all database copies that were on the affected disk. And this is actually a fantastic new technology because it eliminates the need for both us in the service in Office 365 and for on-premises administrators to deploy someone to actually do the disk replacement and to babysit the seeding operation when that disk replacement has been finished. The Replay RPC server wrapper is there as a RPC server that functions as the communication mechanism between DAG members, so that as logs are shipped across our raw TCP socket, the Replay RPC server wrapper can go ahead and pick up that information and transmit it to DAG members so that they know log shipping has been successful. Let's see, what else do we have here? The VSS writer, that is there to manage VSS-based backups, and we're talking about exchange-aware VSS-based backups. So the VSS writer is there providing the interface for VSS applications, such as the plugin we include for Windows Server Backup, and for other software-based VSS applications like System Center Data Protection Manager and so forth. The Active Manager component is largely considered to be the primary component inside the replication service. In fact, sometimes we describe that as the brain of the HA platform. And we do that because it's Active Manager that makes all of the decisions regarding where a database should be located and whether that database should be mounted or not. And in fact, it is the Active Manager component that makes the replication service a required component on all mailbox servers. And the reason for that is only Active Manager can decide whether or not a mailbox database should actually be mounted. Yes, an administrator can still issue a mount request, and yes, the information store itself still does the actual mount, but it will only do so if Active Manager allows it to. And so this is the reason that the replication service is also required on standalone mailbox servers, not just DAG members. Now, the failure item manager is there to both log items and subscribe to items in our Crimson Channel event log area, and I'll show you what that looks like later on. But basically, there's an area within the Windows Server event log that is also required for normal DAG operations, and if we're unable to read from or write to that area, then we'll have a problem, and we'll actually have a mechanism in there that will take corrective action to resolve that. And again, I'll explain a little bit more about that in a bit. The TPR API Manager, TPR, in case you're not familiar with that, is an acronym that means third-party replication. Just as we've done in previous versions, the Exchange 2013 continuous replication technology can be completely replaced with third-party technology that uses our third-party replication APIs as part of their solution. There is actually only one company that makes a solution, and I've yet to run into any customers that are using that solution. However, we still do have support for it within the replication service and within Exchange 2013. The rest of the functionality, the server locators, those are also there to help locate where servers and databases are, and the health state tracker is also there as part of the best copy and server selection algorithm, and some of the other health reporting that we do in terms of managed availability and in terms of giving the administrator information through the Exchange Admin Center and through the Exchange Management Shell. Now again, this is the primary component, but it is not the only component that works to comprise a DAG. So another component, and this is brand new, this is something that we introduced in RTM Cumulative Update 2, which is our latest update that's available. This is called the DAG Management Service, or MS Exchange DAG MGMT, and this is also another service that be running on all mailbox servers, not just DAG members, and it's not quite as large as the replication service. Right now it has 4 components in it: an Active Directory lookup, a copy status lookup, a monitoring component, and then the tracing elements for diagnostic work inside of it. But actually 3 out of those 4 components are not yet doing anything. It's actually only the monitoring component that is active right now inside this DAG management service. And as you can tell from the short name MS Exchange DAG MGMT.exe, it is also an unmanaged code service. Now, the DAG Management Service is really there primarily so that we can offload non-critical functionality from the replication service to an external process. Basically, the idea is that the replication service was getting a bit too large, doing a bit too much work, and we wanted to have a bit more focused functionality. We wanted to narrow and tailor the work that the replication service does. Obviously, the larger the component set of a process, the more work it's doing, and the more work it's doing, the greater the chance that there might be some problem in code or some other issue with it. So that's one reason. Another reason is by separating out some of the functionality that the replication service is doing, when we do have problems that the system can self-detect and recover from, we now have a mechanism by which we can kill lower priority activities, for instance, terminating the management service if we need to and restarting it, without affecting the continuous replication pipeline or without causing database failover and things like that. Now, the way the DAG Management Service has been designed, it's really just a forklifted over code from the replication service. So when it does things like write to the application event log or into the high availability Crimson channel, it's actually going to mimic the replication service. It will use a source of MS Exchange REPL. It will read the same events that the replication service will, and it will basically act as if it were part of the replication service. Eventually, I expect that to change, and the source will change from MS Exchange REPL to MS Exchange DAG Management and so forth. And in the future, we plan on moving more functionality out of the replication service and into this separate management service. So, for example, some of the things we want to move include the auto reseed functionality, the disk reclaimer functionality, a feature we have called dynamic replay lag playdown, and some future work that we have not done yet. And in fact, with respect to the future work, you can sort of get an idea as to where we're going with some of our plans simply by running get database availability group against your existing DAGs, and there you can see some of the properties that we've pre-plumbed the DAG with that begin with auto DAG, but yet are not functional yet. So that will give you an idea as to some of the functions that are coming for the DAG management service. Now, these are the primary services that we have that ship with Exchange. So this is Exchange code. But as you probably know, the database availability group sits on top of a Windows failover cluster. And so that means the cluster service is used extensively with all database availability groups, as is several components of clustering technology. Now, the cluster service is obviously not new. It's been around for many, many years. It was first introduced way back in NT Server Enterprise Edition back in the late 90s. And it has been obviously matured since that time, but things like the short service name and the name of it and the general technology that's in use remains relatively unchanged. Now, Exchange is no longer what you would consider a cluster-aware application. And by that I mean that there are no Exchange resources that are managed by the cluster. Instead, we are really what I describe as a consumer of clustering technologies. The cluster has no idea that we're there, but we know the cluster's there, and we get both technology and information from the cluster. So, for example, we use the cluster's concept of Quorum to manage DAGs. In fact, Quorum is a required element for all DAGs. If you don't have Quorum, you do not have a functioning DAG. And by that I mean you don't have mounted databases and you don't have any client access activities. We also use the cluster's membership and node management features, and we do that so that we can group DAGs together and form a boundary, group servers together within a DAG and form a boundary for continuous replication, that is the log shipping and replay, and of course a boundary for switchovers and failovers as well. And the cluster provides us very good technology for doing that. The cluster also provides us with excellent technology around networking and around heartbeating, or verifying that both network interfaces and servers are alive. Now, some of you may have heard the term heartbeat network in the past. The reality is there is no such thing, and in fact, all cluster networks are heartbeated. And we use that information to determine whether or not a member is up and responding, and whether or not it can still communicate with the rest of the DAG. The last component that we use is the cluster registry, sometimes called the cluster database. And this is an area where we store information that can change very rapidly. So for instance, where a database might be mounted and what its current state is. And we do that because we need a very quick mechanism to share information across DAG members. If we were, for example, to store that information inside Active Directory, we would be bound by AD replication latency, and we would have a much slower sharing of information. Simply put, we would not be able to achieve failovers within 30 seconds if we had to store that information in Active Directory. But because we store it in the cluster registry, we're able to share that information around between DAG members very, very quickly, including information that might change very quickly as a result of manual switchover or some sort of failure. Now, as I mentioned, Quorum is required to mount databases. If the underlying cluster for any database availability group does not have Quorum, then databases cannot be mounted. And that is a simple rule we use to enforce to prevent split brain at the cluster level. Now, Quorum is based on votes, not membership. And the votes can be rigged. You can actually manually take votes away, or, as I'll talk about with dynamic quorum, the cluster itself can also take votes away based on failure scenarios. And this is different from how we did it in the past. And in fact, it's a different approach from what Exchange takes. Now, Exchange manages the quorum model, not the quorum itself. So Exchange does not give votes to or take votes away. And in fact, the whole Exchange management of the quorum model is based on membership, not based on votes. So the fact that you can take votes away, that means that you would require a manual configuration of your quorum model. Now, at any given time, Exchange is going to use one of two quorum models. It'll either use the node majority quorum model, if you have an odd number of DAG members, or it will use the node and file share majority model if you have an even number of DAG members. And based on your membership, that is how Exchange determines which model to switch the cluster to. Now, if you do manually remove votes at the cluster level, that is something where Exchange will now make incorrect quorum model management decisions. That would require the administrator to manually modify the quorum model themselves. So keep that in mind. There now is the ability, unlike what we've had in previous versions, for Exchange to have a different quorum calculation than what the cluster believes is required for quorum. And as a result of that, it may require some manual management as well. Generally, we don't recommend removing votes from DAG members, but there may be scenarios in which you need to do that. For instance, asymmetric deployment across multiple sites where you've got an uneven number of DAG members in each Active Directory site into which you've deployed your DAG. Now, the last part of the cluster is the cluster registry. This is the last component that we use, and as I mentioned earlier, we use this to store database and server information for all DAG members. And we store it inside the cluster database, or the cluster registry, as you can see in the screenshot, because, again, anything that is written to this area is instantly replicated to all other members of the cluster, and therefore all other DAG members. And this is some very basic information that we store in here. I'm going to walk you through what an entry looks like and what the information is in there. But it is important because it's also used as part of the best copy and server selection process. So if there is some sort of failure affecting a single database or an entire DAG member, this information is used to figure out what database should be activated in response to that failure. Now you're seeing it stored in the cluster registry here on a DAG member. We do store the same information in just the generic Windows registry on a non-DAG member, just a regular standalone mailbox server. And again, this is important information that we need because Active Manager requires this information in order to mount databases. So even if you're not replicating in a DAG, we still write this information into the Windows registry, and we still use it as part of the BCSS algorithm as well. Now, if you look at what a typical entry looks like, most of it is pretty easy to figure out what these things mean. I mean, obviously, the name of the active server is the server where the database is either currently mounted, or if you're in the middle of a mount operation, where it's expected to be mounted when that mount operation completes. The last mounted server would be the name of the server on which the database was last successfully mounted, and the last mounted time would be the date and time stamp of when that occurred. Some of the other information that we have here are things like the mount status. So this is where we find out if a database is considered to be mounted or not. And there are actually different levels within the application itself as to whether or not a database is mounted. For instance, the store might have one perspective on it, Active Manager might have another perspective on it, but the reality is unless and until it's written into the cluster registry as mounted, a database would not be considered truly mounted by the system. So it's not until that write operation completes that the mount status of mounted would actually be considered accurate. And obviously the possible values are mounted or dismounted. The other remaining entries, one is admin dismounted? This tells us whether or not if a database is dismounted, if that was the result of an administrator action. That's important for us to know because the system honors all admin actions. In other words, if an administrator dismounts a database, the system's not going to come up and mount it automatically as part of a recovery option because we have honored the administrator's intent here. And then similarly, the is automatic actions allowed, that designates whether or not we're allowed to automatically mount the database on things like startup or failover. So for instance, if an administrator blocked a database from automatic activation, then is automatic actions allowed would be set to false because it would not be allowed to automatically activate. So again, we're not only storing information about the databases, we're also storing information about administrative actions that tell us the intent of the administrator so that the system can honor that intent and not step on the administrator's toes, if you will. Now, in addition to storing database mount status, we also store information about the last log that was replicated for each database. And you can see some of the entries in here. There will be an entry for each database copy inside the database availability group. And you can see these long GUIDs here. And these GUIDs refer to the actual database GUID itself, which you can get with Get Mailbox Database. And we store two pieces of information. We store first the last sequence number of the last generated log in decimal. So if you want to reconcile that with the file system, you would change that value to hex, and then we would go ahead, and then you can go ahead and look at that in the file system and match up the actual log name. And then there's the timestamp for that last log so that we know when that log was transmitted as well. And this is important information because this helps us track where we are in the continuous replication pipeline because the way in which we ship information has changed a little bit in 2013. Now, for instance, unlike 2007, for example, when we introduced the replication service, that used to be a pull model where the passive copy would reach over to the active copy and pull over the logs that it needs. Now we have a raw TCP socket that's maintained between the two systems, and the passive copy simply tells the active copy the last log that it received, and then the active copy sends it any subsequent logs that were generated after that last log. So this is very critical information that Active Manager is storing in here. Now there is other information that we're storing in here as well besides the last log and the other mounted states. But again, much of it is used mainly for internal operations and would not largely be human readable. The last area that we use in Windows is this area of the event log called the Crimson channel. And Crimson, is another name for a color of red, and it's sort of like this red alert or alerting channel. It's really a separate event logging subsystem that Windows Server has for applications that can use that can be used for both logging and internal communication. And what's interesting about this is that applications can both publish events to that, but they can also be subscribers of events to that. So it really acts as a communication channel between components within an application so that they can communicate information that has minimal impact versus system-wide impact. So, for instance, Exchange 2013 has multiple Crimson channel areas. We've got Crimson channel areas for our managed availability technology, and we have Crimson channel areas for the DAG and the high availability technology. And we use this Crimson channel as part of our normal operations. And in fact, it is a required component for the DAG to basically be able to do its thing. To give you an example, anytime that the extensible storage engine has a problem writing to or reading from a mailbox database, that typically indicates some sort of problem. Maybe the database is having some sort of issue. Maybe it's been locked by antivirus software. Maybe the disk is gone, so the database is gone. Any sort of failure that could impact it. When that happens, the extensible storage engine will actually log an event into the Crimson channel. And that event will be monitored by the Active Manager component. And when the Active Manager component sees that event, that is its trigger to take some sort of corrective action, such as a database failover. And so given that we use the Crimson channel in that manner, you can kind of see how important it is for us to do our thing. And in fact, we have automatic recovery behaviors inside Exchange 2013 that that basically will cause a server to fail over if we're not able to leverage the Crimson channel. So, for instance, if during any 30-second period we can't write events to the Crimson channel or we can't read events from the Crimson channel, then Active Manager will take corrective action by forcibly rebooting that server to try to correct the problem, thereby triggering a server failover for the active databases. Here's a quick screenshot just showing you what that Crimson channel looks like. Again, it's got this fancy name, but it's really nothing more than a separate area inside Event Viewer where you can see where these events are logged. So under Applications and Services log, you'll see Microsoft, and under that you'll see Exchange, and then under Exchange you'll see several of these Crimson channel event viewers. And then you can expand each one and you'll see several event logs under these different areas. Now, a lot of the information that is in some of these logs is really for the application itself. So it's not designed to be 100% human readable. But there are events, for instance, in the managed availability area and in the operational area under high availability that are actually human readable, and that may provide you with some useful information about what's going on in your DAG. But don't be too distressed if you start digging through some of these event logs and you find that you can't actually understand the context of these events. They're really designed either for internal application consumption or for consumption by the developer of the application. And so obviously, unless you're on the Exchange engineering team, you won't have the symbols and other tools required to interpret these events. But again, that's okay. This is just part of what the system does as part of its normal operations, and it's largely there for automatic recovery and information sharing purposes. All right, so that wraps up the DAG architecture section. Now I wanted to talk about our updated guidance as to where to place your witness servers for your DAGs. So hopefully most of you know what a witness server is, but in case you don't, it's an external voter, it's an external server that adds a tie-breaking vote to any DAG that has an even number of members. Remember that DAGs are based on Quorum, and Quorum basically is a majority-based algorithm. So you can't have ties with Quorum. If you have two members that believe one thing and two members that believe the opposite of that, who's to say what's right? So we need to have a mechanism where we've got some external tiebreaker that can resolve these sorts of conflicts. So the witness server is not a member of the DAG. It actually doesn't have a vote itself. It really just gives an extra vote to one of the DAG members when it's used. It doesn't contain a copy of the Quorum data. And it is a cluster resource because it's part of the cluster Quorum model. And as a result of being a cluster resource, it is actually represented in the cluster as the file share witness resource. Now, this is not an Exchange resource. So as I mentioned before, there's no Exchange resources managed by the cluster. This is a cluster core resource. It's part of the cluster's Quorum model and part of the cluster core group of resources. Now, when Exchange changes the underlying Quorum model to use the node and file share majority model, it's at this point where the file share witness cluster resource and the actual directory and share on the server specified will be created as needed. And then if you go ahead and change your membership again, then it would be removed when it's not needed. It is heartbeated by the cluster. The cluster uses the isAliveCheck functionality to make sure that it can reach out to this share on this server. And if for some reason it's not available, then the cluster will actually try to resolve that by failing the resources and moving them over to another node to try and bring that resource back up. Now, if the other node isn't able to bring the resource back up and turn it into an online state, then the resource will remain in what's called a failed state. And then we'll try to restart it every 60 minutes. And then if the resource happens to be needed to maintain Quorum, there will be a one-time retry. So it's very important that the administrator maintain visibility of this resource, because even though it's an extremely lightly used file share, it will come into play when that extra vote is needed to maintain Quorum. And if that witness resource is down or otherwise unavailable, it could result in the loss of Quorum, which of course would result in all of your databases dismounting and the cluster services terminating on all of your DAG members. Now, in terms of our guidance as to what server to use and where that server should be placed, if you look at the guidance we had for Exchange 2010, we had very basic guidance. We had a much different architectural model and much different deployment recommendations. And so our guidance was fairly simplistic. We generally recommended that you used a hub transport server somewhere in the same Active Directory site containing the DAG that did not have the mailbox role on it. In fact, Exchange 2010 was programmatically designed to look for such a situation and automatically use that server as the witness server. And the only reason we did that was so that there was a good chance that your DAG would be using a server, preferably an Exchange server, that was basically under the control of the Exchange administrator. And again, that's because the Exchange administrator needs to have visibility of that witness server, particularly knowledge of whether it's up or down. And of course, if the DAG was extended to multiple data centers, then we always recommended putting the witness server in whatever data center that you consider to be your primary data center. The primary data center, of course, being the data center either with the majority of your users or with the majority of your DAG members. Either way, when a WAN failure occurred, we wanted that primary data center to be that data center that survived and kept service up and running. Because of the architectural changes in 2013, our guidance became a bit more complicated. In particular, some of the changes that we make around things like namespace simplification, decoupling of CAS and mailbox, recovery standpoint, changing our load balancing requirements, changing the AD sightedness requirements for mailbox and CAS and so forth. Because of all of these architectural changes that we made, now 2013 actually has support for witness server configuration options that either weren't recommended or were simply not possible in previous versions of Exchange. And of course, we're talking primarily about a third location, such as a third physical data center or a branch office. So in Exchange 2013, the guidance becomes a bit more complicated. But ultimately, the placement of your witness server is going to depend on your business requirements and the configuration objects that are available to your organization. Now, obviously, some of the more simple configurations, that guidance has not changed. If you have a single DAG deployed, for instance, in just a single data center, single AD site, then your witness server should be in that same data center. If you have a single DAG deployed across 2 data centers and you only have 2 data centers, then our guidance would be just like it was in 2010, which was to locate that witness server in your primary data center. Pick one of the data centers to be your primary, and that's where the witness server goes. If you've got multiple DAGs deployed in a single data center, then the witness server is going to be in the same data center, and you've got some additional options. For instance, you can use the same witness server for multiple DAGs, provided that they use a different directory and share. And you can use a DAG member to act as a witness server for a different DAG. So that is one of the caveats that we have. The witness server obviously can't be a member of the DAG for which it's a witness, but it can be a member of a DAG as long as it's not that DAG's witness. So if you've got 2 DAGs, you can certainly use one of the servers in each DAG as the witness server for the other DAGs. And the same thing holds true if you've got multiple DAGs deployed across 2 data centers as well. Now, where it gets more complicated is when you take a single or multiple DAGs and you deploy them across more than 2 data centers. Here again, we always want you to locate the witness server in a data center where you want the majority of votes to exist. Obviously, in the event of some form of networking failure, you need a solution where one of the data centers is going to still maintain majority and keep the system up and running. Now, extending across to more than 2 data centers does provide the benefit of surviving 2 site failures. And in fact, this is one of the reasons we do this in Office 365. But it also allows you to use non-redundant networking devices as well. Now, 3 data centers also allows you to survive the loss of a site and another server, and it could make the witness unnecessary depending on your deployment. Now, of course, this is a much more complicated deployment, and something that would probably rarely be necessary for on-premises customers. But again, it is an approach that we take in the service, so we know it's viable and doable. Now, if an organization does have a third location, then that DAG's witness server can be deployed there for automatic site resilience. The primary requirement we have around this is that the witness server location has to have a network infrastructure that is isolated from network failures that affect the other 2 data centers where you've deployed your DAG members. And this is something that not a lot of customers have the luxury and benefit of having. Even customers that have 3 or more locations don't always have this benefit. For instance, if they use a hub and spoke type networking topology where all networking still goes through a centralized site, you don't have that isolation to allow a witness server site networking infrastructure to survive the loss of a primary site networking infrastructure. So that still may pose some challenges for you or your customers depending on your topology. But as I mentioned a few times now, for all DAGs, the availability of the witness server should be on the Exchange admin's radar. They need to know whether it's up or down at any given time so that they can make informed decisions about, for instance, DAG server maintenance, or about whether or not they can safely turn machines on and off without affecting Quorum and without taking the system down. Now, some folks have asked us about using third locations such as infrastructure as a service. So an example of that would be using Windows Azure. We have been looking into this, but currently, as of today, Azure is not supported for use as a witness server for Exchange DAGs. The simple reason for that is it simply doesn't support the underlying network configuration that we need for using an Azure file server VM as a witness server. I've got a blog post out there that explains exactly what the limitations are. And we are working closely with the Azure team. They do have a formal request from Exchange for this configuration. So if and when they do enable it, then that's something that we would jump on and try to support for our customers. But in the meantime, right now, there are no infrastructure as a service solutions, including Azure or competing services that are supported for third locations. So basically what that means is that if the customer wants to deploy a witness server in a third location, the customer must provide that third location themselves. All right, now let's talk about Dynamic Quorum. And Dynamic Quorum, as I mentioned earlier, is a new feature in Windows Server 2012 and later. And it's a cluster feature where the cluster quorum majority is now determined by servers that are actually active in the cluster at any given time. And this is very different from how we've done it in the past. In the past, quorum votes and quorum majority was fixed and based completely on cluster membership. In other words, how many servers were members of your DAG. So when a server is down, that doesn't change membership. It's still a member, it's just not a functioning member at that time. Now, in Exchange 2013 running on Windows Server 2012, now that's no longer the case. Now, when a server goes down, Dynamic Quorum has the ability to remove that server's vote and then dynamically adjust the number of votes needed for quorum based on that outage. Now, this is a feature that is enabled by default, so it's on all clusters. It is there under the hood, behind the scenes, doing this work and changing the way that quorum is managed. And in fact, now the cluster, as I mentioned, is basically managing vote assignment based on the state of each node. If a node crashes, or if it's shut down or turned off, it loses its quorum vote. If it successfully rejoins the quorum, or the cluster rather, it regains its vote. And so this allows the cluster to increase or decrease the number of votes that are required to keep running based on the servers that are actually up and functioning at any given time. And it also does allow the cluster to maintain quorum and availability during sequential failures or sequential shutdowns. Now, with Dynamic Quorum, it is possible for a cluster to run on a last surviving node. So what that means is I could start out with a very large cluster, and as long as I'm able to regain quorum after a failure happens, then Dynamic Quorum can dynamically adjust the number of votes required and shrink the number of votes needed to maintain quorum. And eventually, I could actually get down to just a single surviving node. This is called the last man standing scenario. And while that does allow you to have a single surviving server up and running, that doesn't always necessarily mean that that single surviving server will be able to handle the entire workload of the rest of the failed cluster. So for instance, you could have as many as 16 members in a DAG, and you could lose 15 of those members and still have one DAG member remaining with Quorum up and running. But that doesn't mean that one DAG member is able to mount all of the databases that should have been spread across 16 other DAG members. It's very unlikely that you will have constructed a solution to handle that. And typically we wouldn't want you to anyway. That's nothing that is going to provide you with any real value from an exchange perspective. The other thing to keep in mind is dynamic quorum doesn't allow the cluster to sustain simultaneous failures and of the majority and keep running. To continue running, it must always re-achieve quorum. So whether you manually turn a node off or whether that node fails, in order for dynamic quorum to work, the system must be able to reestablish quorum before the votes are actually removed away. The other thing to keep in mind is I mentioned that you can manually remove votes from a member as well. If you do that, the cluster won't dynamically add or remove that vote. It'll basically treat it as a zero vote as well. So that could further complicate things in terms of having the system stay up and running for you. So let me give you a basic example as to how dynamic quorum works. So I've got a 6-member DAG, and it's extended to 2 sites. I've got 3 members here, and I've got 3 members over here on the right side. And then the site on my left is my primary site, so that's also where I have my witness server. And basically, at this point, the number of votes that are needed to maintain quorum is a majority of 7. So we've got 1 vote for each DAG member, and then that extra vote that would be associated with the witness server itself. So a total of 7 votes. Now, in the case of a WAN failure scenario where we lose networking in between the 2 data centers, the old rules of quorum still apply. So we've severed the DAG in half, and on the left side we've got the majority, but on the right side we don't have a majority. And so as a result of that, we lose those 3 servers. They terminate because they cannot maintain quorum. But because we have a majority of votes still in the primary data center, the servers in the primary data center can still maintain quorum after this failure. So even though we've had a simultaneous failure of 3 of our DAG members, we still have enough votes to maintain quorum for the solution. So the difference between dynamic quorum and not having dynamic quorum is that value that you see up here. Once the solution is able to regain quorum, or maintain quorum, I should say, on the left-hand side, that's when dynamic quorum kicks in and it reduces the number of votes that are needed to maintain quorum by removing the votes away from these failed servers. So we originally had 7 votes. We lost 3 of them, but we were able to maintain quorum, and so now the requirements for maintaining quorum are now 4 votes. And what this means is, because we need 4 votes for quorum, we can actually sustain the loss of another server now. Okay, we only need 4 votes for quorum. We've got 3 out of 4, which is still a majority, so the system maintains quorum and it still stays running. And in fact, if we lose even another vote after this, again, dynamic quorum comes in and it says I can still maintain quorum because 2 is a majority of 3. And at this point, the single surviving DAG member will lock the witness server and maintain quorum with this last man standing scenario. Now here again, though, this presupposes that this one remaining server can basically bear the entire workload of the databases that were previously spread out on all of these other servers. So that may or may not be the case here. One other thing to keep in mind, whoops, went the wrong way. One other thing to keep in mind is, let's say we're in a situation where we are down to 2 servers and just the witness server. What's actually happening behind the scenes is if we were to lose the witness server instead of one of these servers, then dynamic quorum would still work. It would still adjust the number of votes down to 2, but in doing so, it would take the vote away from one of these members and leave the vote with the other member. So one of these members would have a vote and one would not. And you have no control over which member is going to get the vote. It's completely random and at the basically at the choice of the cluster to make that determination. And so what that means is you need to investigate which server has the surviving vote, because if you turn off that server, one of these servers doesn't have the vote, and the server without the vote cannot stand on its own. So how do you tell what server has the vote? Well, you use the get cluster node PowerShell commandlet to do that. And basically, you're looking at the dynamic weight property, and a value of 1 means that it still has its vote. A value of 0 means that it doesn't have its vote. Now, similarly, there's also this node weight right here. 0 or 1 also applies as to whether it has a vote or not. But the node weight is where you would manually take the vote away from. So if you manually took the vote away from a DAG member, its node weight would be 0 and its dynamic weight would be 0 as well, because we can't give it a never had. But as long as you're not manipulating votes, then it's really the dynamic weight that you're most concerned with. And again, that's going to be a 1 or a 0. 1 means it still has its vote. 0 means that it doesn't have its vote because it was taken away by the cluster itself. And of course, you can also use the validate cluster quorum test to check vote assignments as well. But I find it's really just easiest to use get cluster node to figure out who's got the vote left and who doesn't have the vote left. Now, dynamic quorum does not change the quorum requirement for DAGs. DAGs still require quorum in order for them to do their things. And as I mentioned, for dynamic quorum to do its thing, it still has to have a DAG that can regain quorum before the calculation is redone. But dynamic quorum does work with DAGs. We do all of our internal testing for Exchange 2013 with dynamic quorum enabled, and it is enabled in Office 365 for all of our DAG members that are running on Windows Server 2012. But Exchange is not dynamic quorum aware. Okay, so it doesn't change the way Exchange operates. It doesn't change the way that you would manage the quorum model, and it doesn't really put any administrative burden on you if you just leave it turned on and functioning. Now, our guidance specifically around dynamic quorum does mirror what the cluster team says. The cluster team says leave it on. It will generally increase the availability of the cluster because it will allow your cluster to continue running in failure scenarios that simply weren't possible when the option was disabled. And our guidance from the Exchange team is largely the same. We say leave it enabled for the majority of DAG members. I'll talk to you about a situation where you'd want to turn it off in a moment, but don't factor it into your availability plans. There is an advantage. There's some failure scenarios where 2008 R2 would have lost quorum, where 2012 can maintain quorum, but it really only applies to just a few failure scenarios, and it's nothing that you should rely upon when planning the DAG. So stick with the same business requirements and the same DAG planning mechanism that you use, and plan your DAG as if dynamic quorum didn't exist. Now, one scenario where you might want to turn dynamic quorum off is when you've got a DAG deployed between two sites and you've got better administrative access to, say, Data Center 1 than Data Center 2. So in this case, depending on the failure scenario, if the link between the data centers goes down, the admin might not have visibility into which DAG members are still running. So for instance, if the DAG has 12 members, and 2 of them fail in Data Center 1, and then the WAN link fails, then Data Center 2 could be the side that stays up. And Data Center 2 staying up will happen because that's where the cluster is going to form quorum. And if the admin can't verify that, then they definitely shouldn't do anything like a data center switchover or running start DAG to force quorum or anything like that. So that's, again, one of those strange cases where, yeah, it's probably a good idea to turn it off in that deployment scenario. But for most DAGs, for the majority of deployments out there, you're going to keep dynamic quorum up and running. All right, let's talk about DAG member maintenance. Now, the basic guidance for performing maintenance on a DAG in Exchange 2010 was to run a script that we included called start DAG server maintenance. That put the DAG into maintenance mode. Then you would perform whatever maintenance, install an update, perform hardware maintenance, and so forth. Then you would run another script we included called stop DAG server maintenance, and that would take the DAG server out of maintenance mode and put it back into production. And then there was this optional step of rebalancing your DAG and redistributing your active databases across your DAG members. Now, because of the architectural changes, namely because we've got multiple server roles now all running on Mailbox, Hub, CAS, Mailbox, and and because we've introduced managed availability, now our guidance is a bit more complicated. While we don't include a script for you, we do have these steps documented in TechNet, and these are the exact same steps that we use in Office 365 as well. So basically what you do is you'll run a couple commands. One is called set server component state, and that will take the hub transport component and put it into a state of draining. And that will basically continue servicing the queues, but it won't accept any new messages. We'll do the same thing with another set server component state for the call router component as well. And again, this is where you are allowing existing calls to continue and finish, but you're not allowing the system to initiate any new calls as well. And then in CU1, we introduced this new command called redirect message. And this gives you an even faster way of draining a transport queue to get ready for maintenance. Because you can actually take messages that are in a specific server and redirect them to another transport server in your organization. Then you would suspend the server from a cluster standpoint. You would move the databases off the server, and you would block activation on the server. And then you would use one more set server component state commandlet to basically turn the managed availability responders off so that they're not taking recovery action while you're trying to do maintenance on this server. I always like to verify that the server is in this maintenance mode state. In particular, I always like to verify with get queue that all the queues are empty, so that if I am going to shut down a server for maintenance, that I'm not interrupting message flow or preventing important messages from being delivered to their recipients. Then after the maintenance is completed, then I would go ahead and put it back into production mode, where I would run the server OI offline again, turn it into an active state, turn the call router back into an active state, resume the cluster move, undo the database moves and undo the blocks, and then allow transport to go into an active state and start accepting connections again. Now, one thing I'll point out is I'm actually showing you the scripts that you would use for the Mailbox server role. We do recommend multi-role deployments for Exchange 2013, that is CAS and Mailbox on the same box. But if for some reason you have split out your CAS servers, then from a CAS perspective, you really only need to run this last line here. This set server component state, the name of the server, the component's going to be called server-wide offline because that's the component that controls all managed availability responders, and then you would set the state to inactive with a requester of maintenance. That is the only line that you need to run on CAS servers. Otherwise, for multi-role or for Mailbox servers, you would run all of these lines. And I should say that although we have not put this into a script, there is nothing to prevent you from doing this. If you want to take all of these commands and put them into a single script for yourself, I think that is a fantastic idea. All right, the last thing I want to talk about is managed availability. So managed availability is basically there as a result of things that we learned from operating a cloud service for the last 5+ years. So when we think about it, we've got 3 new tenets around managed availability. One is that it's cloud trained, and that means that there's a lot of benefits that we get from the learnings we acquire from running Exchange Online and Office 365 that we can put into the enterprise product and make it better. The second tenet is that it's user-focused. One of the big lessons that we learned is that a lot of the methodologies we use for monitoring really didn't help us to operate the system. So now what we've done is we've moved to a user-focused approach that is based on the end user's experience. That is really the primary thing we care about in running a service, is that the end user has a good experience. And to protect that end user's experience, we have recovery-oriented capabilities within the system. In other words, in the past, generally when you spoke to teams that needed to monitor things, that you would generate an alert, and the alerts would just come in and let them know that there was a problem that needed to be solved. Now, instead of generating alerts for problems, now the system has the ability to actually correct the problem itself. That's what we mean by recovery-oriented computing. Now, the Exchange team's been operating Exchange within Office 365 for over 5 years now. One of the models we've been championing is what we call the DevOps model, and this is where a developer gets an escalation if their feature is performing badly within the service. Or it could be the opposite, where we don't know of an issue and a customer escalated the problem. But either way, this brings accountability to the development of the software by addressing any software defects. And it also exposes that noisiness of alerts that I mentioned earlier. And as a result of doing this, we've learned a lot. For example, in the Exchange 2010 Management Pack, we shipped about 1,100 alerts. But over years of using that, we found that only about 150 of those alerts were really useful. So within the service, we actually only started using that many, and the rest were disabled. Now, what that means also is that the engineers are on call, so that if there is a problem with one of the developer's components, it drives the right accountability for awareness, because the developer doesn't want to be woken up at 2 in the morning every night to fix their own component. That is going to drive them to fix any problems in their code once and for all in final form, and so that they're not bothered over and over and over by alerts that might happen in the system. And then the last thing that we've learned are some fundamental lessons we learned from deploying at scale. Scale magnifies everything. And so at the scale that we're at now with Office 365, failures are going to happen. They're going to happen every day with every component. And what we found is that we wanted to invest in automation and remove complex redundant systems where possible. I mean, change is going to be a constant, and there's going to be areas where we just want the system to self-correct without having to get administrators involved. Now, what do we mean by user-focused? Well, when we think about the user experience, we think about it in terms of these three touch points, as we call them. One is availability. Can the customer access the service? If they put in their username and password, can they get to their mailbox? And then the second is latency. How is the experience? After they put in their username and mailbox, do they get in their mailbox right away? Or are things working really slow? Or does it take a long time to switch between folders? And then the last metric is the errors. Are they able to accomplish what they want? In other words, if the user is encountering some sort of error message, is it preventing them from achieving their goal? And then the last tenet is this aspect of us being recovery oriented. And so what managed availability has actual capabilities of doing are executing what we call synthetic transactions. Excuse me. And this is where the system is actually pretending to be a user. It's actually accessing a mailbox, trying to do everything that the user would do, and basically validating the user experience itself. So let me show you this animation that explains that. On the left, we have this client. This would be a pseudo client because it's managed availability. And then as far as the topology, there's the load balancer, there's the client access layer, and then there's the database availability group. So the way it works is managed availability will invoke a synthetic transaction, like trying to send a message via Outlook web app. and that will follow the same exact path that a user would do. So if I were a user using Outlook Web App, I would go through the load balancer, I would talk to a CAS, and then a CAS would proxy that communication to a mailbox server. The same thing is happening with managed availability, except that it's not a user, it's internal system code that's doing this itself. But the code is doing that to verify that, in this case, the OWA experience is what we would expect. So let's say that there was some sort of failure that was detected with Outlook Web App. Managed availability has the code in it that can initiate what we call fast recovery. And this is that recovery-oriented action that can do things like restart an application worker pool in IIS, restart IIS itself, or take some other recovery mechanism to fix the problem. So let's say managed availability detects a problem and invokes fast recovery to resolve it. After it does that, it'll verify that Outlook Web App is healthy again, and then it will repeat the process, again, starting with the send, verifying that the send was successful, or discovering that it was not and that there's another failure. Again, managed availability will try to correct the problem, but what's interesting is if, for whatever reason, its initial correction attempt didn't work, it has the ability to escalate corrective action by taking another level of corrective action, like failing over the databases to another server. And again, we're not really interested in root cause or correlation or what the true problem is. All we're interested in is preserving the user's experience, making sure that when the user logs in via OWA, they can get to their database. Now, after a failover takes place, of course, we're going to verify that Outlook Web App is healthy, and it's possible that whatever problem was initially happening on the first mailbox server has been resolved, and now that server becomes a good failover target again as well. Now, in terms of the monitoring layers, we've got basically two different levels of checks. One is what we call a system level check, and the other is that end user experience check. And the end user experience one is the one I just demonstrated. So one of the biggest problems that we had in Exchange 2010 is what do we do with correlation and how do we handle dependencies? So for example, if we had an Outlook Web App problem, how do we know it's a protocol problem versus maybe a database dismount issue or something like that? So what we decided to do in 2013 is rather than try to figure out correlation, what we did was we targeted what we wanted to be clear around what our dependencies are for any given probe or monitoring decision. So the first probe runs on the mailbox server and checks all the guts. And this will do things like a complete protocol execution and go all the way and access the store. And this probe will tell us if we have a problem within 5 minutes. Another type of probe we have is this protocol self-test. So what we'll do is we'll do a self-test. It's what we call a skinny test. We're just looking to see if the protocol can process a request. So this will tell us, for instance, if the protocol is hung, or if it can't talk to store, or if it can't talk to AD. The next is the protocol proxy that tells us whether or not CAS is actually able to proxy the communication to the mailbox. And then the last one is this customer touch point where we actually do the end-to-end. So that was that animation I showed you previously where we're actually testing the whole entire process end-to-end. So with OWA, for example, you can see that our goal is to detect if there's a problem within the protocol or protocol proxy within 20 seconds and to take action on that issue. The customer touch point is there so that we'll know if the user experience is broken within 20 minutes or so. And one of the reasons that we're doing this is to handle dependencies. Again, there's no correlation engine in 2013. Instead, the way we try to deal with it is to differentiate our dependencies with different error codes back to the probes and have probes that don't include touching your dependencies. So for example, if you see this 1 and 2 probe both fail at the same time, what does it tell me? Does it tell me that the store is down? No. It tells me that the protocol isn't working. If I see a working 2 but a failed 1, what does that tell me? Well, that tells me there's a problem on the back end, and it could be that the store is down. So the key pull for a probe or synthetic transaction is to monitor the customer's perception of the service. And that could be the online service, or that could be an on-premises service, which is basically a miniature version of the online service. We're not targeting root cause, we're targeting awareness. The checks are there. They're actually looking at the actual behavior of the system. They're there to look at performance counters. They're there to look at things like CPU utilization, RPC activity, and so forth. And then there's also a notification component in the probe engine as well. In addition to the probe engine, we also have the monitors, and the monitors take the data from the probes and they use it to make the decision rather, as to whether or not there's a problem. So the monitors look at the results of probes and they come to a conclusion. And the conclusion is there a problem or not? And then depending on the decision made by the monitors, either they will be escalated to a responder or no action will take place because it was determined that there's no such problem. Now, if there is a problem, that's when the responders come in, and the responders execute a general response based on an alert generated by a monitor. So you'll never see a responder run unless one of the monitors is red. And there's a bunch of different types of responders. So for instance, there are responders that can recycle application worker pools. There are responders that can trigger failovers. There are responders that can bug check servers, and so forth. There's also some specialized responders as well, something like reseeding the content index catalog if there's a problem with that. So putting it all together, if you look at this managed availability pipeline here, you can see that generally we start out with a healthy monitor. And monitors typically have two states. They're either going to be healthy or they're going to be in an unhealthy state. Now, the probe results are what triggers a monitor to be unhealthy. So at this point, when that happens, the current time is saved, and we start a sequenced responder pipeline. So the monitor starts this recovery pipeline based on the current time. The monitor can define recovery actions at named time intervals within that pipeline, and the component owners defined for a given monitor whether or not it will have a time sequence of events and what those are. So each of the monitors that we have will be different depending on the component that's effective. So T1 is the name of a timed interval within the recovery pipeline. If it's a protocol-related failure, the first activity that we might try might be to restart the application worker pool. If that is unsuccessful, at the next interval, we might try something else. For example, initiating a failover responder, initiating a bug check responder, and so forth. After that, if that's not successful, we might take some additional steps, such as escalating the responder to an administrator. Now, our escalation is all done through event log notification. So if you're using something like System Center Operations Manager, it becomes a wonderful alerting portal for administrators to find out about problems that cannot be automatically corrected by managed availability. So the last thing I wanted to show you is just a few examples of how you can actually use the commandlets such as get health report and get server health to find out the actual health of a server, or in the case of, for instance, this line right here, an entire database availability group as well. All right, so lots more information that you can get from our blogs and from our documentation. And now with that, I'm going to briefly turn it over to Josh, and then we can take some time for questions.
All right, great. Thanks, Scott. Great presentation.